I was an electrical engineer, did a master's degree at the University of Illinois, and did a pre-med at the same time, and switched into medicine, went to Emory University, did an MD there. Then I went into anesthesiology because it looked like that was the most engineering-oriented specialty. Did about 30 years in anesthesiology, did liver transplants, general stuff, tried to avoid cardiothoracic, tried to avoid brains, but I ended up doing a good bit of brains in spite of it. The cardiothoracic surgeons know that they're God. That makes them more difficult to work with. Then I finally got a chance to retire. And now I became a school teacher, and I teach part-time when I can, AP Chemistry, AP Calculus, AP Physics. And then I became an RVer, and we have a couple of RVs now with masts on the back so I can do ham radio. And went to Yellowstone, 6,492 miles, had great fun. Now I'm teaching a technology course at a little bitty, fairly backwards private school. And I'm writing the textbook at the same time because I could not find a textbook that really does justice to all the technology that students need to understand electricity, radio, plumbing, computers, all the stuff that you have to have. Nancy wanted the plumbing connected up for the garden. We do drip irrigation. I just tilled the garden yesterday or the day before with the 34 horsepower diesel tractor, and I'll have to take the carburetor apart on the 14-inch cultivator so I can get it to work again. It's an Amazon carburetor. It replaced the one that came on the Husqvarna because you can't get one of those anymore. So all that technology students need to know, so I'm writing a textbook. I have about 15 or 16 texts on Amazon, so I've got that pretty much down. So our ham radio group, you're going to hear more about it this afternoon. In Alachua County, we've been trying to get a little better, catch up with some of you folks. And we ended up doing a little better at that. And we still didn't have anybody who could do satellites. And I never had much interest in satellites. But we didn't have anybody. We had a FM guy. How many of you can do FM satellites? Raise your hands. All right, how many of you can do linear satellites, CW single sideband? Oh, good. I got one guy I can ask questions of. All right, good. Because I am really a beginner at this, truly a beginner. So that's gonna be pretty obvious, and buddy, you can laugh at it. All right, so the FM satellites are pretty easy. They just have one channel. They act like a repeater. I've never actually used one, but the guy that does was a technician in our group, and he asked the craziest questions, and I finally got used to the fact he was just trying to learn. He's a really good guy, but during field day, those are terribly overridden, so you really can't get through to them. So I said, well, let me see if I can learn how to do the linear satellites. Those are sometimes higher, seem to be a little weaker because they have to spread their power over a larger bandwidth, but there's many kilohertz of space. So that, to me, was a better target for me. So I said, let me figure out how to do that. Well, I didn't know squat about satellites. So those of you who ever tried at these things, you got just oodles of problems to solve. First of all, you got to point at the stupid thing, and it's moving fast. You may only have 10 minutes from horizon to horizon. The one that I had the most success with, I had 25 to 30 minutes at a time. As stupid as I am, I needed every minute. Getting a rotator to work, controlling the rotator. I really didn't want to go the big bucks route. I never thought that was the ham radio that I grew up with as a teenager. So I wanted to learn how to do it myself. You've got Doppler shift. I teach physics. I can't remember the stupid formula, but as things come at you, the frequency appears to increase, and as things go away from you, the frequency appears to decrease, and there's a very complicated formula for that, but thankfully there's software that will do it for you. So you constantly have to be changing both your receive frequency and your transmit frequency. And because of that, and the satellite has an offset to it because it's a crossband satellite, it's operating on two different bands simultaneously, and it's got crystal oscillators or something in there, and its heterodyne oscillators may not be right on target, and I'm using pretty crappy gear, so I know my stuff is not right on target. So you have to find yourself. It's not like just operating on 40 meters where you transmit here and you know you're receiving there. It's you transmit here and try to find where you're receiving. And I had to try to figure out antennas, and again, I tried to build them. And I had the crappiest transceiver setup you'll laugh. So a lot of that. So I didn't have any gear that could do VHF, single sideband, or CW. Just didn't have. All I had Baofungs, right? That and a few old ICOMs and FM stuff. So first I looked into transverters. I'd never used a transverter in my life. But I got one from Ukraine on eBay, and I learned how to use it. And I managed to get it to work with an S-Bit-X. How many of you know what an S-Bit-X is? Oh, one. Okay. So that's the insides of a transverter. They have a whole slew of models. Most of them that I see are coming from Ukraine. I can't afford the M2 models, so if you've got an M2 transverter, you can ignore my stupid stuff. They often have an auto push-to-talk. Doesn't work that great. So I had to solder in a wire so I could control the push-to-talk. So let me see if I can go through the problems and what I tried to do and where I am in trying to solve this. I have made one contact. That's it. And then I quit and said, I gotta make this work better. And I had many other problems to solve, trying to get kids through AP chemistry and things like that. So in the past, back when I was a young thing, people used separate hardware systems to figure out how to point their antenna. Now you can just buy it. You can go to CSN and buy their CAT system or SAT system, and it combines the software and the controller. You got the money, just buy it, and it will drive a Yaesu rotator. But now there's ways to do it that you can just do yourself, and so that's what I like. So this is the old-fashioned way. I've never seen one of these. I just saw pictures. You buy this big $699 job and connect it up to your computer and whatnot, and that's all now replaced with the SAT system. But I wanted to do it myself. So K3NG developed the software for this a long time ago. How many of you have ever used any K3NG software? Oh, I'm alone again. Well, he developed Arduino software, so I printed out a board, got it made in China, and it allows me to control a rotator directly from K3NG software using a $5 Arduino, and it'll control a Yaesu rotator directly. Use some output relays from Amazon, control them with some MOSFETs, and that board is, if I remember right, on PCBWay. You can get that board yourself. Don't need an expensive controller. That's the basic schematic. It's really very, very simple stuff. The work that I did was trying to make the connectors fit on the circuit board. Getting the footprint of the connectors right was the hardest part. I did rewrite some of his software and picked options so it would work. So you use the USB input of the Arduino, connect that up to your computer, use some software we'll talk about in a second. I used real simple analog potentiometers, the same way Yaesu does. Read those potentiometers, and that senses your angles. DC output controls, modern Yaesu rotators are DC controlled. You can use either 12 volts or 24. 12 goes slower than 24. So I gave you the list of where this project is on PCBWay, and also a couple of article that I wrote about it. This is a picture off of my PCB layout software. The red are the lines that are on top of the board, and the green are on the bottom of the board. I did learn how to do a copper pour, so I get a lot better shielding now. You need some software. How many of you know who Asher Farhan is? Well, Asher's in India. Asher makes about 3 or 4 different radios right now. He's got thousands in the market. They're not the greatest, but he's a really smart guy. And he said, just try gpredict. Gpredict is free, and it's available for almost every operating system. So I got gpredict. Nice display, does the 2-line updates, Keplerian elements, all that, right out of pre-calculus. Controls the rotator via HamLib. How many of you have ever used HamLib? Oh, a few more there. So there you're talking about rote control D and rig control D, daemons. Runs on just about anything you want. I've had it on both Windows and Raspberry Pis. It's all free. And I got the rotator working, but I could never get it to work with my radio because my radio was an ICOM 820H and it's got a sub and a main. And rig control D just couldn't figure out how to deal with that, or at least I couldn't. I searched all over the internet for anybody who'd ever made this work, and I couldn't find anybody who'd ever gotten it to work with an ICOM. Yaesus apparently are easier. So I went to SAT PC32. This was developed by a German ham. You can use it for free for a while, and you end up paying $50 for something. I think it's well worth it. It properly controlled the ICOM transceiver on the very first try. I was like, holy cow, this is amazing. It uses DDE, and I don't even know what that stands for. It's a Windows kind of thing to control the rotator. And I found a third-party piece of software called WISP that could read the DDE and would then be able to control Yaesu-type rotator. So it's going into my board, and the board is actually sending the DC to the rotator. So this is really neat. It'll download all the satellites that you want. They occasionally fall out of the orbit. You have to update your files and get the right ones. There's a few tricks to that. So rotators. So if you've got $700 that you just like to let go of, you can just buy the G450. Do you have one of those? Then what do you use?
I used an ARRL antenna by hand.
Oh, you are sharp. I can't do that.
I'm even more rudimentary than you are.
Well, my hat is off to you. If you can hit a satellite holding the antenna in your hand, you're pretty good. Well, the G5500 is basically a horizontal azimuthal rotator on the bottom, and then they put a rotator that turns a boom to go up or down on the top and double the price. Well, I already had the bottom rotator because they're not that expensive, and I didn't want to pay for the top rotator. So I said, can I build this myself? And what I know about mechanics, I can strip down a 4-cylinder engine, but to ask me to build something, this is a little different. So there's a guy, VK4GHZ, he's brilliant, and he had all this stuff on the internet about how to build this, and I couldn't quite do what he did, but I got a 90-degree gearbox off Amazon, and I said, let me see what I can do with it. And I learned how to use a linear actuator. They're only like $30, and they stick an arm out and pull the arm back in. And doggone it, I made the thing work. And you can see it sags, but it worked. And I had elevation and azimuth control, and I could track this thing right through the sky. And sometimes I could even get it to work. So this is a picture of what I built. So as you can see, I used ARRL, just like the ARRL antennas by that company, and PVC pipes, and I built a 450, a 440, and a 2-meter, and unfortunately I don't think their performance is that great. They're offset by a quarter wavelength. I have circular or elliptical polarization. I did the matching feeds, and I had a heck of a time trying to get the match. I'm just terrible at creating matches on 2 meters and 440, so I'll tell you how I improved on that later on. But this actually worked, and I actually could hear the satellites and hear other people just having great fun. And obviously they had much better equipment than me, and it was just like schedules for them. Oh, I'm going to meet you at 7:30 on this pass. And I'm like, can anybody hear me? So, but I did do it. So I decided to build a better rotator. And it's been a while coming, but I'm making a lot of headway. So I decided to build this around much stronger aluminum masts. But in actuality, I'm going to have to drive a Schedule 41-inch PVC through it so I can have non-conductive boom in the long run. But my aluminum mast so far is working well. I used a bigger linear actuator, paid about 40 bucks for it, still using potentiometer angular monitoring. I learned how to tutor on Wyzant. So instead of teaching in a formal setting, I had a whole bunch of students all the way from New Jersey to California trying to learn physics and chemistry and calculus. And I made so much money trying to help those poor devils pass their courses that I could afford to buy a 3D printer. And my kid told me, buy the PS1 and get this thing that sits on top of it that holds 4 filament rolls. So I did. And then I picked the worst, hardest 3D CAD blender. It is, I mean, I must have 400 hours into learning how to use Blender. But I can now build almost anything I want. So I have built every one of those pieces that you see, designed every one of those pieces except the gear. I managed to find a program that would build the gear for me, and then I just take it and attach it to what I want. So I don't think we've got a pointer. But the hardest part, I built the bushings. The bushings hold the aluminum mast onto a piece of wood, because wood's real easy for me to work with, a lot easier than metal. This pressure treated wood. You can see the linear actuator going vertical there, and its arm has a 6-inch travel. The 4 bushings are built with 4 millimeter thick ABS plastic so they won't melt in Florida sun, and I hope they'll be strong enough. The orange arms in the center are what drive the movement. There's a name for that, cantilever or something. And then those have a gear tooth on them that fits on a separate purple gear that drives the little 10K Adafruit potentiometer, which is mounted in a small orange box that I 3D printed also. Then I had to build a limit switch because I was terrified that this actuator, which has got like pounds and pounds and pounds of thrust to it, it'll just tear my plastic apart. So on the far end, on the up end, all I need is 90 degrees of rotation. I got way more than that, but at the top I have it maxed out, and the linear actuator has internal switches that will stop it from going past its endpoint. But on the close side, I have to provide my own limit because it can go further back and just tear my arm off. So on the left side, you can see a little orange piece that I 3D printed. And there's a little micro switch on there, and there's a purple arm that comes off of the aluminum. And that will shut off the linear actuator and keep it from destroying my plastic. All of this is 3D printed. So anybody in the world can replicate the entire thing. The files will, when I get them onto my GitHub, will be for free. And so you can build this thing for pennies. We're looking at about maybe $6 worth of filament. It's not much. Now, to print it, you're going to spend about 12 hours of total printing time because you have to print them one at a time. But you can print the whole blooming thing. And then I got U-bolts to hold this to a 2-inch mast. And so far, it looks like it's going to work fine. I don't have it in the azimuthal rotator yet, but that will happen very soon after I get my cutoff wheel working again so I can cut it down to size and run the 1-inch PVC through it for the booms. Frequency control. So I told you I couldn't get G-Predict to do what I needed. SAT PC32 did work, could control both the main and the sub of an 820H, which I bought used from a friend. And it can also control all the ICOMs, so it's pretty cool. It does that via the open collector ICOM CIV control that's very popular and very cheap to use. The 820H lacks a spectral display. This is a problem because when you're not on an FM satellite, you're on a linear satellite, you could be kilohertz off and your signal's not strong. You got to find yourself. So with no spectral display, you spend a lot of time, and you only got a quick pass. You spend a lot of time hunting for yourself. So if I could get a spectral display, it would be way easier. So it said, well, look, I've got this SBitX or ICOM 7300. Both of them have a spectral display. I got a transverter. What if I just feed the receive signal to those as well, and I can then see myself? And it worked. So now I could see my own signal. I mentioned there's a lot of drift in all of these oscillators. The satellite can drift as well. My stuff certainly drifts. And using the SBitX or an ICOM, I prefer to use the SBitX a lot cheaper. I did blow out a preamp once when I did something stupid and sent transmitter power into the preamp, but that was another issue. So I split the receive signal, so you got a 3 dB problem with your noise figure already when you do that. Portion goes to the 820, a portion goes to the transverter off to an HF radio on 10 meters. And I had to write some code to get these to track. So I wrote some code that runs, it's C code. I cheated and used some other help from other people. And it reads the CIV signal, and then it gives commands to the SBitX to put it where it ought to be. The SBitX has a real neat toolkit that allows you to do that kind of stuff pretty easy, and all I had to do was read how to do it, generate the C code, and I'm done. So that allowed me to keep track, and I could also put in changes to the offset so I could keep all these receivers tracking each other. The result, however, was a fairly complicated setup. I used about half of my garage, and I had all these pieces of equipment because I built almost all of it. So I got my own rotator controller, and back then I had preamps and all kinds of stuff, and I did manage to blow some stuff up. So I was using this really cheap ICOM 828s that only has about 40 watts of output. One time, it just quit making output, and I thought I've killed the poor thing, but it started up again. So I don't know what happened, but it works. So with the antenna gain, you have the problem that the satellites are not sitting still. They're tumbling, and they tumble at different rates depending on how they got launched and what happened recently. I guess, and whether or not the Soviets have been trying to catch them or anything. And one of the ways you can build it, there are lots of ways to build a circular polarized antenna, but the easiest for me is to take two Yagis, put them at 90-degree angles, put them a quarter wavelength apart because the wave spins 90 degrees every quarter wavelength. You have a 3 dB loss just to combining two 50 ohm antennas in parallel. And I really stink at matching UHF, VHF Yagis, because Yagis have a really low impedance just because of all the parasitic coupling. The typical match is to get your Yagi to 50 ohms if you can, and then use a quarter wave matching transformer to get it to 100 ohms, and then use a BNC T connector and put them in parallel. And that's sort of what I tried. I had a heck of a time with those arrow inserts. They make inserts for these arrows, but they don't fit right and they don't hold. So I had to learn how to kind of weld them or braze them or crimp them or anything I could do to make them solid. Then I used threaded rods because they're not long enough to make a 2-meter antenna, but with threaded rods I could get them to be long enough. I'm going to do something different next time. But I did sort of get this to work. I used an idea from a guy a long time ago, showed how to build a very simple antenna. It uses a J section for the driven element. I've never done that before. I managed to get it to work, sort of. There are many other ways. Some people use a folded dipole instead of the J section, and just recently I've realized that I need to learn how to do gamma matching because I think that might be my solution. And probably how many of you have ever done gamma matching? See, he knows how to do it again. All right, so I built a 4-element 2-meter antenna. And here are the dimensions that I had to make the adjustments to the size because I had slightly different width of my elements compared to the original position. And then I spent a lot of time in an antenna lab trying to improve this thing and make it better. And I sort of got it as good as I could. And then I built a 6-element 432 Yagi. Of course, there's 2 of each of these. A lot of work building those. And here's some of my trouble trying to build the J-driven element. I had to use soft copper tubing from Home Depot, refrigerator, water, ice maker tubing. And I had a heck of a time trying to get that to mate with aluminum arrow shafts, but that's another story. Well, I wanted to know, am I going to blow out my receiver? So how much isolation do I have between these two antennas? So this is a map of the isolation. Looks like it starts at 100 megahertz and finishes at 500 megahertz, and it's 40 dB of isolation between the two antennas. These are passive devices, so the isolation will be the same both directions. So I'm not really at any risk of blowing anything out. That was good news. I created an antenna farm and I calibrated it with a standard 2-meter dipole, and then I measured the gain of my homemade antenna, and it was underwhelming. It did have some gain, but it was nowhere close to what I was hoping. So just recently I have purchased a 70 centimeter Yagi that certainly was made in China, and man, I'm impressed. The fit, the finish is so much better than what I can do. And they did the gamma match. And I'm like, oh, so that's how you do that. So I'm going to attempt gamma matching myself, and I'm going to try to potentially buy a second one of these and drill the holes or offset the booms and make this into a cross-polarized circular polarization. And if this is really 50 ohms, then this is going to be a lot better than what I did. So now I have to figure out receiver sensitivity. I'm listening to all these guys, and they just have no problem at all. And I'm like, I can barely hear them. You know, what is it that they know? Well, then I look up, and M2 makes these antennas with like 19 dB of gain. And they're 20 feet long. And I got to get this to field day. You know, I got to get it in the back of a pickup truck. I've got an antenna at home that's 25 feet long that I scarfed off somebody, but there's no way I can rotate that. The coax run adds loss, and if I have to use my spectral display, that's more loss. And my 820H is an older radio, and I have no idea how good it is. So the question was, can I use a preamp? Well, of course, gas FET amplifiers are what you want. And you can do those. They're only $376 for a cheap one. $500 or more for a more expensive one. There's not that many still on the market. ICOM quit producing the ones they're doing. But I found these Chinese ones, and they were only like less than $20. And I don't know if they're telling the truth or not, but they say they got a noise figure of 0.6 dB. And I looked at the specs on the typical gas FET, and that's easily attainable. Getting under 1 dB noise figure is not that hard to do. Just got to buy the gas FET, put it in a little circuit, which is more work than I want to do. So I bought these things, and then how can I keep from blowing this deadgum thing up? So my ICOM can put out 10 volts on the receive line when it's receiving, but the ICOM can make the transmit line either one of the output connectors, and once I hit the wrong switch and popped my transmit onto the wrong side. So I decided, can I build a circuit that will sequence all of this and keep me from making these stupid mistakes? And really, people who know what they're doing buy something called a sequencer. And you can buy that too. And there's a lot of designs for that, and M2 makes them, and other people make them. But of course, I did my own, right? So here's my board for the sequencer. And of course, it uses a nano, right? $5. And it's got the same output connectors, and it's just slightly different. It's got the same display, and that actually works really well. The 820H is an older radio, and it doesn't even have a power level control. You've got your choice between low and high. That's it. And there's an etiquette thing on satellites that you're not supposed to hog all the power, because it's only got so much power, and it's got to split it among all the users in the bandpass. So there's a trick for the ICOM that you put a transistor 9-volt battery and a rheostat, and you feed it into the ALC input on the back, and you use that to set your power. So I said, well, I can do that. The Nano's got a pulse width modulated output, and I can easily control the pulse width, and I can filter it and get the DC, and it works. And I have control of my power, and I have sequencing, and I can make it delay as I switch from, and it reads the push-to-talk line, and it knows exactly what's going on, and it works. I was really pleased when I got that working. This is my workshop bench. It's pretty crappy, but and of course I 3D printed that box for the sequencer. 3D, and there's another problem I had with HVAC system blowing out, and I built a sequencer for it too, and kept it from blowing out. It saved me $1,000 with every blower motor. So can I make a 2-meter preamp relay system that will click the relay in and out so I can save the preamp, put it in and out at the right times? And coax relays are not cheap if you've ever looked for them. So can I design that too? So I built a board for 2 meters, and I'm not much of an RF engineer. I had never done microstrip before. How many of you have ever designed microstrip? Well, I hadn't. So I had to read about how to do microstrip, and I kind of got a 2-meter board that actually works. My 2-meter board worked pretty good at 2 meters, but the isolation at 900 megahertz was really pitiful in these crappy $4 or $5 relays that I used. And so the thing oscillated like a banshee at 900 megahertz and blew out my preamp after toasting a couple of protection diodes in the process. But you can buy diplexers. Comet makes them, everybody makes them. They'll switch 70 centimeters from 2 meters and separate them perfectly, like 40, 50 dB of isolation. They're cheap, and that makes a great low-pass or high-pass filter depending on which you need. Throw that into the mix and I can stop this oscillation cold, and it works. And so I've got a preamp for a few dollars for the board, $14 for the preamp. The relays are $4 or $5 each, $50 for the low-pass filter because I'm too cheap to build it myself. So then I said, well, can I build a UHF switcher? Can I build a relay system that will work at 70 centimeters? And there's a guy in California, another ham, who had done a bunch of research on HF3 Axicom relays. And he had the data that suggested they had adequate separation that would work. So I bought the $15 each. And it's like soldering a surface mount thing. It's really tiny wires. And nobody has the footprint. So I had to design my own footprint on the PCB board for these things. And I got it pretty close to where it worked. My microstrip calculations were pretty pitiful, and my SDBRs were horrible. But I guessed that I had put too narrow a microstrip, so I just put wire on top of them to decrease the ZO of my microstrip, and doggone it worked. I got my through SDBR down to very reasonable numbers, and so now I had a UHF preamp switcher for like nothing, $50 or less, and it works. It'll work fine at 70 centimeters. I was a little nervous. These preamps, they have gain all the way to 4 gigs or 6 gigs. So just to be careful, I don't know if you can see it, but at the very bottom, that is a low-pass filter. It's just a turn or so of wire and 1 capacitor, but I just wanted to kill the gain above 500 megahertz just a bit because I was terrified that I'd blow out another one of these preamps. So far, it has worked. So I think I now have a UHF relay, and I can switch in and out a cheap $15, $16 preamp with a gas FET and much less likelihood of me destroying it because it's all DC controlled now. I had to, y'all know what a bias T is? It's the thing that strips off the DC off. You send it down the center conductor and it strips it off. Well, if you're doing this and you're sensing that with a transistor, you got to have a good bias T because it cannot respond to the transmitter or your host. So I had to build a 2-section bias T, but I got enough performance out of my bias T that it worked, and I had ICOM control of the preamp as a backup to all my other controls. The bottom yellow line is the SDBR of my UHF switcher. That purple line is probably phase or something, I don't remember. But my SDBR at, I think it was 440 megahertz, was 1.227, and I was really pleased with that. If I can get that SDBR down to that, this is going to work. So my UHF relay design works. I've actually done a second board layout to get wider strip lines, but I don't think I've sent it off to have it built because I just didn't have time. Finding myself on the SBITX. If I can just send a series of dits or dots, because I do a lot of Morse code, then you can see yourself on the spectral display, and then you adjust set PC32. You hit the plus button or the minus button a lot of times until you hear yourself in the receiver and you're done. Now you can hear yourself and you can call CQ, and that's how I made one of my contacts, one of my only contacts, And finding yourself was the biggest problem in all of this. And I already mentioned this controls this, and I already mentioned how I control that. So where's next? Well, I'm going to bring this Rotator 2.0 to life, finish the dual axle hardware. I'm going to put in 1-inch Schedule 40 PVC. It looks really strong enough to do this. I think that's going to be a big success. I have about 24 inches worth of the 1.5-inch aluminum mass material. That goes straight through the 3D printed, and it won't bend, so it's not going to break my bushings. I don't know how strong my bushings are, but I'm going to find out. Then I can publish, assuming this doesn't break, all the STL files, and then anybody can print it themselves. You can even have it printed for you. A lot of libraries now do this. In fact, I went to a library to get advice from a guy who had the exact same printer. So how do you do this? How do you do that? And he taught me how to do some things. Install the sequencer, install the preamps, track the satellites on receive, and then start transmitting and find myself again. And then hopefully I will start being able to work stations again. I'm a HFCW guy. This is not my cup of tea. I just decided, what the heck, I wonder if I can make this work. So I'm teaching these high school students. And I carry this stuff up all the stairs to their classroom, and I show them this, and their eyes are just like saucers. You made that? So I'm trying to open their eyes that ham radio offers a chance to do all kinds of cool stuff. This is real robotics. This is not robotics to get something to go along the path on the floor. I'm tracking a satellite for real. I'm using Trig. It's all built into the software, but really complicated software by other hams is tracking this satellite. It's GPS synchronized, so my times are right on the number because seconds count in this business, and I think it's going to work. Whoops. So that was it. Now, any questions? You must have something.
I really admire you for what all you've done with what you've used. I mean, ICOM 820 is certainly not state-of-the-art technology.
No. You can see the transistors.
And there's not that many people who build their own sequencers. As a matter of fact, you're the only person I've ever met. So I really admire you for what you've done.
Yes. I created my own course. I convinced the headmaster of the little private school that I wanted to create a course for technology for high school students.
So how many of these students are actually now starting to take up the banner for what you've done? Now they're interested in
Well,
this is kind of interesting.
the school I'm at, I would characterize as having a massive outreach and extraordinarily poor academics. I've never seen such poorly educated students in all of my life. I introduced imaginary numbers to them a few days ago when I was trying to we're going through the technician license class. So I was trying to explain phases, and I said, what the heck, I'll teach them imaginary numbers. They had never heard of it. They've never had chemistry. They're 11th graders. Their education is so sad, so sad. The school is so limited in their resources. You could walk into a school like that and volunteer. Now look, I have to go there every day. It's a lot of work for me. But I'm creating an entire course. Every Friday they get a quiz on the ham radio license. And they're very fascinated with the stuff that I'm showing them, but their level of technology, folks, in order to get them to pass a quiz on the technician printed questions, I have to go through them twice to get them to do it. If I only go through them once, I'll get D's on the quiz on Friday. If I go through it twice, I got a good chance at B's. It's that bad. They do not study.
No shining stars?
Sir?
No shining stars amongst your population students?
So they were supposed to give me 15 students. 3 showed up. I have 3 students. They all tell me they have ADHD. Sometimes they don't even show up because they live very far off and their parents are disadvantaged, and sometimes they just don't come to school. So it's an uphill battle. I've been teaching technician license courses for a decade now, and this is by far the hardest. They can't divide with a calculator. I am doing long division on the board because they don't know how to divide. And I'm doing long subtraction on the board. They have to know how to change the 2 meter band. What frequency is the 2 meter band? This is a hard problem for them. So I have some of the most disadvantaged students. These students were headed for Walmart or McDonald's or JCPenney's as salesmen, and I'm showing them a movie about a calculus professor who turned around American education called Stand and Deliver. And I'm trying to raise their thought process that there is nothing that stops you from learning this stuff. And one of my best moments, one of my kids who flunks all of the exams, he was out for like a week. They all had the flu, and for like several days I had no students. And then they started to trickle back in, and then this one kid, he missed a whole week of school. He missed the day I went over imaginary numbers. They couldn't believe that there is the square root of -1. And then I tried to explain, well, you square it and you get back to -1, right? And they're like, really? So this kid shows up, and I just mention imaginary numbers and the square root of -1, and all of a sudden he gets all excited and rips out his math book and says, we had that. And I couldn't believe it. The math teacher at this school actually knows what he's doing. He's taught in colleges. He's a pretty decent teacher. It's just the clientele he's working with. I walked in on him one day, and he had the quadratic equation up. So I know he's teaching math. But I asked these kids, what's the difference between an insulator and a conductor? And of course, it's free electrons, right? Charge carriers. They have never had chemistry. So they don't know about electrons. No clue about delocalized electrons. Forget the Schrodinger equation. Forget Bohr's model. They've never had any of it. So I don't know what I'm going to do. I may try to create I've already written a textbook for high school chemistry laboratories. That's on Amazon. So I'm working with a really difficult crew. And I think 2 of them may pass the technician. I'm doing ham radio as the first part of this technology course because it allows me to attack all kinds of things. So when I discuss, how are you going to teach decibels to these kids? How are you going to teach decibels? They've never heard of a logarithm. So I had to convince them that there were numbers that when you add them, they multiply. And that when you subtract them, they divide. I had to convince them that that was possible. And I told them about Napier, the Scottish priest who figured this out in 1617. But I 3D printed a slide rule. I learned how to do that, and I put the numbers on it. I found a design online, and I just added the numbers to it. And I said, look at these 2 number lines. When you add 3 inches and 4 inches, you don't get 7 inches, you get 12. It multiplies. So they were the only kids in the school who had ever seen a slide rule, and they had their own because I can make them for $50 each. So they went home with orange slide rules because I had neon orange with black letters. And that went through the school. You know, slide rule? I explained to them it slides and it looks like rulers, so it's called the slide rule. So I'm introducing technology to them. I carry in antennas, I carry in radios, I carried in, who knows what an MFJ 259 antenna analyzer is. I carried one in, I put a capacitor on it, I measured it at 2, 4, 6. I showed them it was a hyperbola. I made an inductor with some coils, and I showed them it was linear. And then, believe it or not, it had a series resonance, and it was obvious when I put the 2 together. And I said, that's your first tuned circuit. You can see what happened to the impedance. So they're seeing stuff that no one else in their school has ever seen. And if it'll make a difference in their lives, I don't know. Yes?
Gordon, you seem to, I think, invented some simple solutions to some problems with some devices you made in this project. You had a rotator controller that
Yeah.
you built. There's a few items I saw in your presentation that, I could see all sorts of different uses for. So when you give this presentation again, you might want to think about pulling those out and say, well, what else can I use this for? Because there's some, specifically that rotator control thing. there's a common problem in some of these rotators that they burn out the control box.
Yeah.
And to get another one is an expensive deal, and it almost looks like maybe you
No, I've got it.
there that you can put together for very little.
Oh yeah, we use the K3NG,
Yes.
and it's computer controllable.
I know MFJ made an alternative control box for those Mason rotators for a while, and the box was $300, but it solved your problem.
Yeah, mine's dirt cheap, and I even 3D printed the box for it.
And there's a couple other things I saw too, so my hat's off to you.
Well, it was fun. I just don't like spending money, and I like building things.
I enjoy building. Well, I want to thank you very much. And